scatter plot, but we shall use only 5 of them. We need to define some new words here. Is response variable. Whenever you hear response variable, it means y-axis or y. And when you hear explanatory variable, it means x. So the independent variable is now the explanatory variable. We can also refer to the independent variable as the predictor variable. So x will be called the explanatory variable or predictor variable. And then we shall try to draw a scatter diagram. And that is going to show the relationship between two quantitative variables. So actually, we are going to be using two quantitative variables, all right, to make the linear regression. Okay. All right. So we can actually start immediately. So I would like you to put this data in your L1 and L2, where the L1 is cloud head speed. So this question says, in this example, draw a scatter diagram. And by the way, before we draw a scatter diagram, let me first of all go to the kinds of scatter diagrams that we have. So I'm going to move down, and actually show the scatter diagrams. That way we know when we see the particular one. All right, so let's look at scatter diagrams. Scatter diagrams. So this is one, but I want to see all of them. Okay, so if a scatter diagram looks like the one we have here, the scatter diagram looks like number 1. Let's call this one number 1, where the response variable, the y-axis is here, the x-axis is here. We would say it is linear. Why? Because all the points are going to the same direction. If I eyeball that scatter diagram, I will see that the line of best fit, the line that will fit this scatter diagram, is a line with a positive slope. So we shall call it a linear, but it's not linear, just linear. I would say I'm just going to say high, not just linear. So I said there is a high positive linear relationship, high positive linear relationship between the explanatory variable and the response variable. So if I see that the points are pointing to the right direction, even though the points are not on the same point, they're not collinear, but I can see that the line that will fit this scatter plot is a line with a positive slope. We say that the data has a high positive linear relationship. If the scatter plot looks like this, which means all the points are going to some direction, but they are going to the same direction to the left. And the line that will fit all of them is a line with a negative slope. So we shall say again, there is a high negative linear relationship. High negative linear relationship between the predictor variable x and the response variable y. There's a high negative linear relationship between the predictor variable and the response variable. If the scatter plot looks like this, you can see that it's not linear. This is not linear, so we say it is non-linear. And look at this one, it is non-linear also. This one has no relationship. This one has no relationship. Why? Because it's scattered everywhere. If I eyeball it, doesn't give me any direction. So I can see that if I draw a line, the line of best fit will be a horizontal line. Okay, so I am actually going to draw. I am going to make 5 lines here. So I'm going to write kinds of scatter plots. Kinds of scatter plots. All right, so how many do we have? All right, so I'm going to describe one that looks like an L graph where x is the explanatory variable, y is the response variable, and all the points are on the line. All the points in the scatter plot are on the line. So when I have a scatter plot that all the points are on the line, I will say perfect positive linear relationship. Perfect positive linear relationship. And so what does it mean? It means that the relationship between x and y, the explanatory variable and response variable, it is perfect because all the points are on the line. So the points are collinear, like the one we did in geometry, all the points on the line. Perfect positive linear relationship. Okay, now I'm going to draw another kind of scatter plot. This kind of scatter plot can look like it's the opposite of this one that we just drew. Number 2, suppose I have an L graph where x is the explanatory variable, y is the response variable, and the line of best fit is a straight line such that all the points are on the line. All the points are on the line. All right. So all the points are on the line. Then it is another perfect relationship. But this time, the perfect is negative. Perfect negative linear relationship. So this one has a perfect negative linear relationship. So I'm describing the relationship between x and y, the quantitative variable x and y. And x is the response variable. I mean, explanatory variable, y is the response variable. Okay, so this is perfect. Why? Perfect because all the points are on the line. Perfect negative because the slope of this line is negative. The first one is perfect positive linear relationship because the slope of the first line is positive. Perfect, all the points on the line. So another kind of Scatter plots could be an L graph like the one we have already seen. Well, the line of best fit is a line with a positive slope, but all the points are not on the line, but they are close to each other. And I cannot look at it and say that the line of best fit has a positive slope. So we will not call this one perfect. We will say high positive linear relationship. So right here, I will say there is a high positive linear relationship. So see, the difference this time is I did not call it perfect. I called it high. Why? Because even though if I eyeball the line of best fit is a positive, has a positive slope, but the points are not on the line. All the points are not on the line, so it's not perfect. It is high. So high positive linear relationship. That's why I called it high positive. So you should know the difference between perfect positive linear relationship and high positive linear relationship. Okay. Well, suppose let me have an L graph, and in this L graph, I have a line with a negative slope, and all the points are actually not on the line, but they are close together. You can actually eyeball the scatter plot and see that the line of best fit has a negative slope. So in this case, we shall call it, this is X, this is Y. Remember that X is the explanatory variable, Y is the response variable. That's what we call it in this section. And this section, we said that we are doing bivariate data. We can call it regression analysis, but it is just linear. When you get to calculus or pre-calculus, then they will call it, they can give you another kind and call it quadratic regression. And if they can give you exponential regression, they can give you quartic regression. But right now in statistics class, we're only doing linear regression. Okay. Now, this one here, I will address it as a high negative linear relationship. So that is a high negative linear relationship between the predictor variable or explanatory variable and the response variable. Don't forget, Y is the response variable, X is the predictor or explanatory variable. Okay, well, let's another situation is number 5. In this kind, I just draw a scatter plot that has no direction. If I eyeball my scatter plot, it's actually scattered everywhere. So we will say there is no linear relationship between them. There is actually no relationship. No line fits the scatter plot. It's scattered everywhere. You can't make anything out of it. So this is your predictor variable, which is X, and the response variable, which is Y. All right, so we call this one. So this is X, this is Y. So we say no linear. Don't say no relationship. Say no linear, because it might actually, so there is no linear relationship between X and Y. the explanatory variable, and the response variable. So this is the kind of, all these 5 are the ones we want to discuss, even though we have seen quadratic, but we're not doing quadratic regression in our class this time. We can actually see exponential regression, but we are not doing them now. Well, we are only interested in linear regression analysis. So don't forget, when all the points are on the line, we say perfect positive linear relationship. When all the points on the line and the line has a negative slope, we say perfect negative linear relationship. When all the points are not on the line, but they're all, you can see that the line of best fit is going to the right, we say this is a high positive linear relationship. Another way of saying this is there is a high positive linear relationship between the explanatory variable and the response variable. Right here in number 4, the line of best fit is negative. All the points are not on the line, so you cannot say perfect. But you can say there's a high negative linear relationship between the explanatory variable and the response variable. Linear relationship. Okay, so this is a little introduction of the kinds of scatter plot we can have. And so we also said that number 5 is just, it's everywhere, it is random, it doesn't have any direction. So there is no, you will say no linear relation between X and Y. There is no linear relationship between X and Y. Okay, so I'm going to go to the PowerPoint again. So we just used, we just found out there are more scatter diagrams than this. All right, we talked about the kinds of variables we are using. We are using 2 variables, and they are quantitative. Both of them are quantitative. All right, so I already talked about having a negative association. So 2 variables can have a negative association, and that means the line of best fit is negative, and so on. So you can read this: 2 variables that are linearly related are negatively associated when above average values of one variable are associated with a below average of the other. That is, 2 variables are negatively associated if whenever one variable of one increases, the other one value decreases. This is what it's saying. For example, suppose this is X, maybe X dollars, and this is Y, and the line of best fit is negative. So suppose this is X dollars. As the amount of money increases, the Y decreases, see? So if it is money, but it can be any other thing. All right, so we say it is, the relationship is negative. Okay, so this is, we're talking about 4.1. So this works, I mean, PowerPoint is 4.1. We will soon calculate. So now we will go back to the question on linear regression, where we shall use our calculator. So let me make sure you know. We don't want you to do this calculation by hand. First of all, the properties of R, which is called the linear correlation coefficient, is that R has to be, I'm going to write it down so I'm going to write the properties of R. That way you cannot, okay, it's actually here. So these are properties of the coefficient of correlation called R. The first one says the linear correlation coefficient R is always between 0 and 1. So you can write it with an inequality. In other words, you can write it with a number line such that 0 is here and 1 is here, and this is -1. Okay, so the R, the value of R can be from -1 to 1. Okay, we already said that if R is +1, then that is a perfect positive linear relationship between the explanatory variable and response variable. In other words, whenever you describe a statistical plot or whatever you describe a scatter plot as a perfect positive linear relationship, then the coefficient of correlation is +1. If you describe R as perfect negative, then the coefficient of correlation, R, is -1. If R is closer to +1, we shall say high positive linear relationship. If R is closer to -1, we shall say high negative linear relationship. If R is 0, we shall say there is no linear relationship. Okay, so let's go to the next slide. So we can have a situation where there is no linear relationship. Okay, so property number 6. Property number 6. If R is close to 0, I already said that, then there's little or no evidence of linear relationship. Remember, you must put linear there. Because if there is no linear relationship, there could be another relationship. There could be quadratic, cubic, quartic, sinusoidal. I mean, there could be some other relationship, but we are only interested in linear relationship. So R close to 0 does not imply no relationship. Everybody must know this. You must know that if R is close to 0, it does not mean no relationship. It does not mean no relationship because there could be a relationship that is not linear. That's I want to emphasize that. So if you write no relationship, the computer will give you a wrong answer. I mean, give you a 0 because really there could be a relationship, but it's just not linear. All right. Property number 7, the linear correlation coefficient is unitless. Therefore, you cannot say the value of R is in feet. It cannot be in centimeter. It cannot be in yard. So the value of R has no unit, unitless. So the unit of measure of R and Y plays no role in the interpretation of R, has no unit. Okay. Property number 8, the correlation coefficient is not resistant. It's not resistant. Therefore, an observation that does not follow the overall pattern of the data could affect the value of the linear relationship. Another way of saying that, an outlier could cause a high positive linear relationship or high negative linear relationship. Therefore, it is not resistant to outlier. That means that outlier can affect R. So we got to be careful. If there is an outlier, we might have to take it away so that, and by the way, remember the other day I said that a lower outlier can be calculated with Q1 minus 1.5 IQR. IQR is interquartile range. This is L1. And an upper outlier can be calculated with, if I say it is L2, then it is Q3 plus 1.5 IQR. So you can be told to calculate outlier, but anyway, you can as well use your calculator to calculate outlier. All right, so let's go to the next slide. The reason why I'm using PowerPoint this time is I actually found out that some of you don't have time to study. Okay, some people don't have time to study the PowerPoint or read the ebook. Okay, now let's see again. Our book drew all kinds of scatter plots, but we already know this. This is the perfect positive linear relationship. This is strong or high positive linear relationship where R can be 0.9. Here, perfect R is 1. This is not high. The relationship can be low. This is a perfect negative linear relationship. All the points are on the line. Remember what you called it in geometry, collinear. This is a high negative linear relationship. And this is not as high, but it's a negative relationship. So we can say it is moderate. This is no linear relationship. Remember, you cannot say no relationship. You're not allowed to say that. No linear relationship. Right here, you will say no linear relationship because it's not linear. All right. So when you see this one here, suppose that the data are equally dispersed in the 4 quadrants, then the negative product resulting from the data in quadrant 4, 2 and 4 will offset the positive product. So the result is a linear correlation coefficient of 0. This one is scattered. Okay. All right. So I think we need to start with this one. So let's get a calculator and start with table 2 here. And after this, we do the first one. So I'm going to pull my calculator up, correlation coefficient. In other words, compute R. A scatter diagram of the data is shown. The dashed line on the scatter diagram represents the mean of X and the mean of Y. Okay, so let's go. X is going to be in L1, which is the explanatory variable. So we put the data in X. So 1, enter, 3, enter, 3, enter, 6, enter, 7, enter. And then we go to L2. 1 is paired with 18. 3 is paired with 13. 3 is paired with 9 again. 6 is paired with 6. 7 is paired with 4. All right. So the next thing is we want to find the scatter plot. So let's do scatter plot first. So even though they gave it to us, so we do a scatter plot of this data. I select plot 1. Scatter plot is number 1. So what type of statistical plot am I doing? I am doing the scatter plot. Now, where is my L1? My L1 is the explanatory variable. My L2 is the... All right, I'm ready to zoom 9. Before I zoom 9, I want to go to my Y equals and see if there is anything in my Y equals that will make my graph look... Okay, there is none. Okay, another thing I want to do before I actually do a linear regression is go to mode, M-O-D-E, and make sure that all the things are on the line on the left. So I want to put it in radian. Also, I want to tell my calculator that I need 3 decimal points. So I'm going to get 3 decimal points instead of 9 decimal points. Another thing I want to do is go to diagnostic. And where is diagnostic? I am going to catalog. Everything is in catalog. So second catalog. Then I'll turn diagnostic on. So I'm going to turn diagnostic on. So turn diagnostic on. I am looking for diagnostic. I see it here. Then I hit enter. So diagnostic, I just turned it on. Okay. Now I'm ready to do this calculation. And by the way, when I turn diagnostic on, it will help me calculate the coefficient of correlation and coefficient of determination. Coefficient of correlation is R. If I square the coefficient of correlation, I have R squared. And R squared is coefficient of determination. So I go to start. And by the way, I already know that my data is in L1. Let me go back there. So my data is in L1, and I'm doing a scatter plot. Everything is good. So I can zoom 9 so that I see. So I see a scatter plot. The scatter plot looks like it's going to give me high negative linear relationship. So the scatter plot will give me high negative linear relationship. And then the next thing I want to do is go to start, STAT, and try to put a line on my scatter plot. Well, there are two kinds of linear regression. Number one looks like the slope-intercept form of equation of a line. And the other one, number two, actually number 8, is still a linear regression with A and B switched around. So C for number 4, number 8. I like to use number 4 though, so I'm going to select number 4. And then L1 is my explanatory variable. L2 is my response variable. I don't have frequency, even though I have L2. I don't have frequency, so I'm going to clear that. What I do have is 2 variables. I'm doing linear regression of 2 variables. So the L2 in my frequency, in my start, is not actually frequency. All right, so now I'll go to store equation. So my calculator is asking me, do you want to store your equation in any of the functions? Yes, I want to store my equation in Y1. So I'll tell my calculator, please store my equation in Y1. And this is how to do it. Vars, Y-vars, function Y1. And I'll calculate. Remember what I have told my calculator already. I told my calculator that I want 3 decimal points. I want you to calculate the coefficient of correlation for me also. That's why I turned diagnostic on. And I also want coefficient of determination, R squared. Okay, so I will just ask my calculator to calculate. So it tells me this is the kind of equation I picked, number 4. Tells me that the slope is negative. That means that the line of best fit has a negative slope. The y-intercept is 18.667 to 3 decimal places. The coefficient of correlation has, and by the way, whenever the slope is negative, the coefficient of correlation is negative. The sign of the coefficient of correlation and the sign of the slope are always the same. The sign of the coefficient of correlation and the sign of the slope are always the same. R squared is coefficient of determination. Okay, so suppose I put graph. The line of best fit draws on my scatter plot. If I push trace an arrow down. Then I see the equation. So this is the regression equation. And that regression equation says y equal to negative 2.167x plus 18.67. So you copy this equation. And by the way, this equation is also in y1 because you stop it there. If you want to see all of them, you arrow to the right, the same equation, and then you write the equation. So now this is the regression equation. But one of the questions is find R. So let's do it again so we can find what R is and make R is coefficient of correlation. And when we find R, we want to establish the kind of relationship between the X and Y. So I'm going to start arrow to calc again and select number 4 again. I'm doing it again. And my explanatory is in L1, response is in L2. I don't have frequency. My equation is still in Y1, so I can still write it again. So if I'm telling my calculator to put the equation in Y1, I put vars, Y vars, function Y1, and then you calculate. Okay. All right, so now I have my equation is right there. I have coefficient of correlation. It is negative 0.946. In other words, there is a high negative linear relationship between the explanatory variable and the response variable. There's a high negative linear relationship. Why the high negative? 94.6% is high. The sign is negative. So it's high negative. It is not perfect because all the points are not on the line. Note that the coefficient of determination is 89.4%. Very high also. So the kind of relationship in this data is linear, high negative linear relationship. Okay, so we just did an example. And by the way, we can now go to, I don't want to do it by hand. See, these are examples of how to do it by hand, but trust me, you want to do it by calculator. So do it with calculator as much as you can, so you will finish. Anyway, so this is an explanation of coefficient of correlation again. You might want to know how to explain the coefficient of correlation. The coefficient of correlation starts from -1 to 1. That is, you can say -1 is less than or equal to coefficient of correlation is less than or equal to 1. In other words, the coefficient of correlation can be -1 perfect negative linear relationship or 1 perfect positive linear relationship. It can be 0, no linear relationship. If it is near 0, you can say low negative or moderate negative. Okay. So the next thing we want to look at now, we have already calculated one. So the one thing I want to do is go back. So next time we shall study part of the PowerPoint, and then we'll go to the worksheet, the practice test. So I am now going to the practice test 2, which I already posted in Blackboard. Practice test 2. And let's see if we can answer the questions, some of the questions there. We have already learned enough to answer some questions from this practice test. So question number 1 says match the linear correlation coefficient to the scatter diagram. So this one is the coefficient of correlation is 0.523. All right, 0.523. I'm going to look for the one that is near the midpoint. Remember, it is positive 0.523. So I'm going to look. So let's go down and look at the all right, so I see that this one has a high positive, but it's not that. So this is matched to number. I can match this to A. So this is A. This one has a high negative linear relationship. So I can match this one to B. This one has low positive, almost zero. So I can match this one to B, or this one. And D is perfect positive, so I can match this one to D. So after you read the properties of normal distribution, properties of correlation coefficient, you can go ahead and answer this question. All right. So we just did number one. Therefore, we can actually answer some questions. Explain what each point on the least square regression line represent. All right, so each point there, each question there, you can say whether it is, okay, number three. Number three is probability, so we're not in probability yet. So let's do number four. So we are going to do another example. We already given a lot of things. I'm going to use the graph, draw a scatter plot of this. So I am going to get my calculator again and do a scatter plot of the data in number four. All right, I like to use my L1 and L2. So I'll go to Start, Edit, and I'll clear L1. I like to use my L1 and L2. So I'll clear L1 also. And then X should be in L1. So 1, enter, 1, enter, 3, enter, 4, enter, 6, enter, 6, enter. And then I go to L2 5.1, enter 6.5. That's 6.5. So I will go to 6.5, enter 5.3, enter 3.6, enter 2.2, enter 2.4, enter. Okay, when you finish, the two last numbers must be on the same horizontal line, and eyeball the data you plugged in. Is there anything that looks off? Did you make a mistake? People make mistakes. So, and then I'm going to do a scatter plot. So let's do a scatter plot. All right, so how to do a scatter plot? Remember to go to mode and set your mode to 3 decimal places, and then go to diagnostic and turn on diagnostic on like I did before. So second, start plot. I'll select plot 1, and then I tell my calculator that I want to do scatter plot. And where are your L1 and L2? Explanatory variable is in L1, response variable is in L2. So I'm going to zoom 9 to see my scatter plot. So I did zoom 9, and this is actually looking like it has a high negative linear relationship. Before I start, I'm going to clear the equation in y1, and I'm going to zoom 9 again. Zoom 9. So I have a high positive linear relationship. So the next thing I want to do is, in this scatter plot, I will superimpose a line on it. So I go to Start, arrow to Calc, number 4, linear relation in number 4. My data is in L1 and L2. I don't have frequency list. I want to put my equation in Y1. So that is vers, Y vers, function Y1. So I just instructed my calculator to put the equation, regression equation in my Y1. So now let me hit enter. Okay, so my regression equation says that the slope is negative because there's a high negative linear relationship. Note that whenever the slope is negative, the coefficient of correlation is also negative. If you square R, you get R squared. R squared is the coefficient of determination. The y-intercept is 6.703 or 702. If I graph the line in y1 will draw on the scatter plot. So the line of best fit, it has a negative slope. If I push trace and arrow down, then I'll see the equation, regression equation. So if I'm told to write the regression equation, I'll write it here. So this is the regression equation right here. You write your regression equation here, and that is negative 0.72x plus 6.702. So that's your regression equation. And interpret a scatter plot. We did that. Describe the properties of linear correlation. We did that. Compute and interpret a linear correlation. We did that. Determine whether a linear relation exists between two variables. We tried that. Actually, we did that. Explain the difference between correlation and causation. We haven't done that. So, but our next class, we're going to do that. But anyway, what it means that if there is a relationship between two variables, one causes the other. It does. The other. No, really, unless the person is sick. So sometimes an outlier can cause relationship between X and Y, but most of the time, it may not actually be that X is affecting Y. Going to school is not affecting you having headache. It could be because you are not feeling well. It could be somebody who is sick. Something else is wrong, because going to school does not cause headache. So if you draw a line of best fit with people going to school and having headache, there could be mistakenly association, a mistaken association between going to school and having a headache. But actually, having a headache does not cause. So we mean by relationship does not mean that negative relationship sometimes does not mean X causes Y. It could mean that there's an outlier, there's something else. There's something else causing it to be a high positive relationship. All right. Do you have any question? So welcome to Unit 2. I'm glad you finished your Unit 1. Do you have any question about the test you just finished?